Okay. So you bring down the 6, you should have 6 times 7 x to the 6 minus 1, plus bring down the 4. 4 times 2 x to the 4 minus 1, minus bring down the 3. 5 times x to the 3 minus 1, plus what is the power of the x on pi? 0. So if I bring down a 0, it's just 0. Okay, let's see. Read what you get for the derivative.
42.
Wait, start with f prime of x, if you would.
F prime of x equals 42x to the 5th plus 8x cubed minus 15x squared.
What do you think? Thumbs up, good. Thumbs down. You need to fix something.
I don't remember that.
Oh, yeah. Good. Okay, now the next one I'm going to use the dy dx notation. What type of rubber band, Kyle? Okay, I'll just give you a whole selection, and you just find one that works. Okay. Okay, if we're going to take the derivative of y, I'm going to write d dx of y, and then I'm going to be taking the derivative of this guy. This is the notation that when we get to implicit differentiation, you'll need to know. Excuse me. The derivative of y is just dy dx, right? And that y just kind of scoots into the fraction. Equals the derivative of 1/3 x to the 6th power is, you bring down that 6, so would you agree that it becomes 6/3? X to the 5th power, and technically this is dx dx, derivative of x with respect to x, but dx divided by dx is just 1. So we don't generally write it. So I'm not going to write it on these ones. So you don't need to worry about dx dx, but in a month or so it's coming up. Plus, bring down that 3 and multiply, we get 12x squared. Technically this would be dx dx. Now e is a constant, right? So when you times bring down your 1, it just stays negative e x to the 0 power, which we don't need to, oops, to write. And as we found out from the last two, the derivative of a constant is always 0 and be gone, because there's no x. And the last thing I need to do is change 6 divided by 3, that will simplify to a 2. That's the derivative. Okay, try number 4. We can do y prime. Since it says y, either do y prime or dy dx. Interesting, right? Where's the x? In the denominator. So, I could rewrite this. Y equals 3 times x to the what power? Negative 2. Negative half would be square root in the denominator. Plus x to the negative 1 minus 1/2 x to the 4th. Okay, if that helps, I'll finish it. That includes y prime or dy dx. make sure you carry the y prime down in front. And so this would be y prime now. Question? And then at the end, make sure if you have negative exponents, so you put them back in the denominator.
I like these.
Kind of fun. Okay, so especially at the beginning, you might want to consider showing your work. And what have I already done incorrectly? Yeah, I need to put the prime. Make sure you're using correct notation. Okay, and it is -2 minus 1, which means that you're going to go more negative. Bring that -1 down, times 1, x to the -1 minus 1. Bring the 4 down, so I have -4 times 1/2, x to the 4 minus 3. So I'll have 1. It will be 3 minus 1. So y prime equals -6 over x to the what power? Third. Since I know this is negative, I'm just going to put it in the denominator right now, and that would be positive. Minus x over, oops, not, minus 1 over x to the second power, because this would have been -2, and so make it positive, you bring it down to the denominator. And -4 divided by 2 is -2, this guy's positive, x to the third power. Okay, how'd you do? So if you see those negatives, the first step I would do would be, if you see a denominator with an x, the first step I would do would be make them negatives in the polynomial. Okay, so the derivative of the function f at a point x equals a is the limit. This is just an alternative way to see the same thing. F prime of a equals the limit as x approaches a. I want you to look at what's the difference between this definition and the definition on the front page.
That's like average. The one on the front is right.
Yeah, it's like your y2 minus y1 over x2 minus x1. As you're approaching, and this time you're approaching a specific value, wherever a is, okay? Okay, differentiate using the alternative definition. So in your directions for your homework, sometimes it says you must use the definition, which means you have to do it the long way. If it doesn't say using the definition, then you can use the power rule. Okay, so square root of x. To find f prime of a, we're going to take the limit as x approaches a. This is like the average rate of change, longhand, of, says f of x, so we keep anything inside as an x, minus, what would be next? It says f of a, so how would I write this function in terms of a? Square root of a over x minus a. But if we have plug in a right now, we have division by 0, right? Can't do that. So math's all about manipulating to get what you want. Okay, manipulating to get what you want. So you've heard of rationalizing a denominator, right? When we have square roots in the denominator, well, I'm going to rationalize the numerator, and it's going to work out. I'm trying to put the square root somewhere else. Okay, so what does it mean to rationalize? A fancy form of 1, yes. What would that fancy form of 1 be? I guess I can do this. A little close. Plus, what's this guy called? Conjugate. Okay? So, when you do that, we get the limit as x approaches a. Square root of x times square root of x is just x. Because 1 is minus, 1 is plus, first you square the first term, square the last one too. In between the first and last, put subtractor through.
Plus minus.
Yeah, because this guy's going to be positive, and this is identical, except for it's minus, so they cancel out. Then we have a negative root a times root a will just be minus a. So it's just the first guy squared. Root x squared is just x. Second guy squared, which root a is just a. Subtract because it's the product of a sum and difference. Versus this one, x times root x is x root x. X times root a is a positive x root a. Okay, Margarita we get right here. Multiply those two. Except for that's an a. Yeah, negative a root x. Alex, what about here? Good. Okay, now what? Can I just plug in a right now?
Yeah.
Maybe, but I think we still have a problem with 0. Okay, so here we use a conjugate. Now I'm going to factor by grouping. Favorite F word. Factoring by grouping. Hello. Okay. The limit as x approaches a, the numerator is x minus a. Do these two, this is factoring by grouping, do those two have anything in common that can factor out? I believe they do. X. And the remaining would be root x plus root a. Do these two have anything in common that could be factored out? And what type of a? Negative a. Which gives me root x minus root a remaining. Plus root a.
Couldn't you adjust left instead of distributing the left there? You know what I mean?
Oh, yeah, we're backtracking a little bit. That's good practice. Because that's actually what I'm doing is I know these two match, so factoring by grouping. Factoring by grouping, yeah. So we just undid what we just did. Huh. Good catch, Kyle. X minus a times root x plus root a. What am I doing?
What are you doing?
I don't know. I've looked at my paper. What's the deal? Oh, no, it's changed. Has it changed? Yeah, it's changed from the beginning because now we have that conjugate. So we just added the conjugate in and you don't have to factor it out. Because what I want is these guys to cancel out so I get my division by 0 is gone. So we could have done that right here and not multiplied it through. Except for, unless we have to multiply the numerator through too, so that wasn't a waste of time.
So you just leave the denominator?
We can leave the denominator.
Alright, I got it. So you'll have x minus a over.
I have 1 over root x plus root a, and I held the limit because I haven't substituted. But now when you substitute, we get 1 over root a plus root a, because I'm inserting a wherever there's an x, which is 1 over, how many roots of a do you have? 2. 1 over 2 roots of a. So we did need to use the conjugate, but we only had to distribute the numerator because the denominator is kind of a waste of time. But eventually we got it. So that we could plug in. Okay? Now, that worksheet we talked about at the beginning of class is going to become applicable. What's going on? Because this guy has 1, this guy has 1. So you're adding the coefficients. Yes, I inserted an A in that X. Okay, we're going to now graph and see what happens. How is the derivative related to the parent function? Okay, so starting with the cubic. F of x equals x times x plus 2 times x minus 2. Can you tell me where this cubic has x-intercepts? -2, because of this guy. X equals 0, because of this guy. And x equals positive 2. Excellent. Okay, so my graph over here, I know it's going to cross right here, -2. I know it's going to cross at 0. I know it's going to cross at positive 2. Okay? Well, let's get a couple other points. What's happening at f of -1? You might want to do this up above if there's room. F of -1, work that out, and do f of positive 1, so we can see some curvage. We know this is a positive cubic, so it's going to go up, curve down, and then go up, right? Okay, once you think you have the y values for those x coordinates, turn to your neighbor and see what they got. One of those signs is off, I think. Good. Yep. Okay, so when you insert -1, f of -1 you get 3, f of positive 1 you get -3. Okay, so you go up to there and down to here. So essentially our cubic function looks something like this. Up, up, and away, right, with arrows. Now, guys, on your AP exam, you have to label your functions. What's this guy called? F of x. And it even tells you at the beginning. So we're using the F notation, F of x notation. So just at the top of the arrow, F of x. Please, please, please label those. Okay, now let's use the power rule to find f prime of x. Well, we're going to have to multiply those through, right, to get the power rule. Let's just do the binomial times the binomial really quick. What will we get when we multiply x plus 2 times x minus 2? X squared minus 4. First you square the first term, square the last one 2, in between the first and last, but subtract you through. That's allowed when 1 is plus, 1 is minus, and everything else matches. Then the middle term always cancels out. So, f of x becomes x cubed minus 4x. Will you please find f prime of x using the power rule? Okay, Rebecca, what do you have for us? Thanks for going back and saying that. F prime of x equals 3x squared minus 4. Do you agree? I think I agree. Okay, so f prime of x is now what type of a function? A quadratic. So when we graph it, we should have a quadratic. Do you remember how to graph quadratics? This came up on some of your homework. The axis of symmetry goes through the vertex. How do you find the axis of symmetry of a quadratic? It's the beginning and the end of the quadratic formula. Negative b over 2a, the beginning and the end of the quadratic formula, which is nice because it goes with a quadratic. So our x-coordinate of our vertex would be, the b value is 0, divided by 2 times 3, which is just 0. Okay? So we plug in 0, f prime of 0, negative 1? Yeah, negative 4. So our vertex is 0, negative 4. Okay, so let's graph this thing. We'll do it in the next graph. 0, let me go down a little bit. 0, negative 4. Okay? How do you get 2 more points?
No, it's like positive, so it's going up.
We know it's going up. It goes up 3 over 1 for the first set of points, right? 1, 2, 3 over right and left 1. And that's enough, right, to graph a quadratic. So make sure it's curved, and make sure you label it. This is f prime of x. The first guy I have in green is called your position function. Once you take the derivative is f prime of x is your acceleration. Those who've taken physics have talked about that before, right? Acceleration. Okay, before we move on to taking a second derivative, let's talk about what has happened. And you might not want to mark this up. I'm going to erase the marks I make. Tell me when the position stops increasing. Okay? How is that related? So essentially it's near the negative 1. How is that related to the derivative through negative 1? How are those two sections related? When the derivative, or when the function, the position function is increasing, how does that match the acceleration, the derivative function? Okay, maybe we'll look at the next section too, see if you can find a connection. Get a little skinnier. Okay, then it turns, and the position function decreases until, tell me when to stop. Okay, so at positive 1, so if I follow the derivative to positive 1, and then we have another set. I start increasing again near positive 1, goes up, and near positive 1. Do you see any relationship with that? What happens to the derivative? Remember, the derivative is the slope. Well, it's the derivative is the acceleration of the position function. It's telling you what's going on with the position function.
So up until negative 1, you're increasing.
You're increasing, which is what type of number if you're increasing? A positive. If you're above the x-axis, are you positive? Okay, then also we turn and we start decreasing. Decreasing is what sign? If you're below the x-axis, are you negative? And then we start increasing, which is what sign? And so if you're above the x-axis, be positive. Okay. So a nice thing happens with these zeros. That maximum will always be your x-intercept. The minimum, because that's when you're changing from increasing to decreasing, right? That's when you're changing from positive to negative. Those will always be your x-intercepts of the derivative. Okay, let's take another derivative, a second derivative, which we've never done yet, and see what happens. Find f double prime of x using the power rule. So we left off, f prime of x was 3x squared minus 4. We can keep taking derivatives until there's nothing left to take derivatives of. Applying the power rule, we write f double prime, so two little tick marks, of x equals, take that derivative really quick. Okay, Alex, what did you get? What do you guys think? Yep, because if we take this 2, pull it down, 2 times 3 is 6. We decrease that by 1, it becomes 1. Minus 4, well, constant, the derivative of a constant is 0. Because it's x to the 0 power, so we times in by 0. Great. What type of a function? F double prime is now what type of a function? Linear. So when we graph this guy, it should be a line. And you can see because of mx plus b, it crosses through x equals, or y equals, sorry, what's the y-intercept? 0 with a slope of 6 over 1. So next graph. Okay, crossing at 0 with a slope of positive 6, so it should be going up or down? Up. 6, oops, 6 isn't really on our chart, so I'll put it right there.
So what happened?
I'm sorry?
So half the value.
Yeah, it's true. Okay, so we should label always f double prime of x. This becomes your velocity function. Let's see how it's related to the one before it, which was f prime. Okay. F prime was decreasing until, well, actually f prime was decreasing for a while, wasn't it? I'm trying to get a different color I'm going to use. Maybe, I don't know, green. Tell me when f prime stops decreasing. Oh. So right there, if you're decreasing, what's your sign for velocity? So is it true that those are negative to the y-axis? And then we turn around, and right there is that transition point, so you should be crossing the x-axis. We turn around, and positive, positive. Then keep going. There's another one. F triple prime. Then we were at f double prime of x was 6x. Please use the power rule and find f triple prime. By the way, after triple prime, we stop writing tick marks because we start writing just the number, like f to the 4th, f to the, in parentheses generally, 5th. Because who wants to draw 5 tick marks? Like we don't start doing like tick, 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 slash, tick, 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 slash, nothing weird like that. Okay? So after the triple on the 4, we start actually writing the number. Okay, this one we should get it pretty quick, I think. Ethan, what's the f triple prime of x equal to? Great. And what type of function is f triple prime of x equals 6? It is a line. It's a constant function through f equals 6, right? F equals 6. So this is f triple prime. of x, please label. And this guy is called the jerk. Okay, position, acceleration, velocity, jerk. Now, does it make sense that this is all above the x-axis? Does it make sense that f triple prime is completely above the x-axis?
I don't know, because what do you mean by that?
Look at the velocity. Is the velocity increasing the entire time? So it's always positive. So above the x-axis is always positive. So it does make sense for it to be completely above the x-axis. Okay, so a few things of what relationships you see on the graph. Maxes and mins of the line of f line up with the what of f prime. So look at the first one. Maxes and mins of f line up with what of f prime? The zeros, the x-intercepts, or the solutions. Okay, so I'm going to put x-intercepts. What happens on f prime when the slope of the tangent line of f is 0? So coming up to f, tell me when the tangent line of f is 0. I'm positive, because I'm going up, and then all of a sudden, is the horizontal line going to be the slope of 0? Okay, what happens here? That's a slope of 0. Yeah, what? Oh, that's just the height right there. What happens on the tangent line? Right here, and isn't it also right here? Will I get another tangent line with slope of 0? So on f prime of x, what do we have when we have a tangent line with slope of 0? And x-intercept, same answer. Different vocabulary. Yep, you get an x-intercept. On f prime when the tangent line of f on f prime when the tangent line of f is 0. When f is increasing, f prime is doing what? Where is its location? When f is increasing, so this yellow one, f prime's location was what? Location. Above, meaning all of these values are positive. Yeah? It is above the x-axis or positive. When f is decreasing, the derivative when you're decreasing puts the derivative where in relation to the x-axis? Below or negative. And we're going to squish another 2 lines on there, or we didn't talk about what this is actually called. Right here, this guy where it's concave down and then it turns and becomes concave up. The point at which it turns between concave down and concave up, that's called the point of inflection. I lost the word for a second. Point of inflection. Point of inflection. Point of inflection. I want you to look and see what happens. Going back up. What happens to f prime at this point of inflection? What do you mean it changes its direction? Yeah, so right here, this guy all of a sudden goes from concave down to concave up when it hits the y-axis. So this guy goes, at the y-axis, all of a sudden goes from decreasing to increasing. So we're going from concave down, switching to concave up. It will change from decreasing to increasing. So when F is decreasing, the F prime will give us a minimum. But what if you're starting from concave down, so you start increasing, and then switch around to decreasing? If F is increasing, the derivative will pop out a maximum. Okay, I have two things for you. Ooh. One of which is extra credit. I know, right?
Okay, down to what? Yes.
That'll get you to wake up a little bit. But I'll give that to you after this one. Here's the next homework set for chapters 3 and 4. You already did the first one, identify qualitative graphs worksheet. Okay, so there's 3-1, you can see. Now for the extra credit, I'll hand it to you first. I think this is pretty creative, and I can't claim that I created it. I just found it. Okay, what is it? A recipe. But why would this be a calculus extra credit?
Did this solve for recipe?
How many eggs do you use?
The limit of the...
Well, the limit as x approaches negative infinity of negative 3x minus 23 over 2x minus 3 is how many eggs you use. Yeah, I wish I could claim this, that I was this creative and did this, but we're going to store it and use it. Look on the back. Check those out. Measuring cups and teaspoons. Does it say 1 cup, 3/4 cup, etc.? No, it's relabeled all of them. So, your extra credit assignment is to solve this and then document that you've actually made them via like picture or video that you actually made them, and change your measuring utensils, and if your mom doesn't want you to write on them, write on some tape that comes off, okay? Change your measuring utensils to limits.
You don't own any measuring cups?
Dollar store. You just eyeball it, and then my food wouldn't come out very good if I just eyeballed it. Okay, so.
How do you eyeball it if you never have measuring cups to know what to eyeball?
Yeah. Okay.
She does. You don't.
So work out the limits so you can make them. Make them. Document in some form that you're actually making them. Pictures, video, whatever. And show me that you've actually changed your measuring utensils into the form of limits. Cool? I'll give you a couple weeks. You can do it over the weekend or when you have time. Yeah, I like that. Okay, so you have a little bit of time to start working on your derivatives. Open up your book.